Hello, we are now in quarter 2, module 1. In the next 2 weeks, you will be able to demonstrate understanding of the properties of organic compounds in terms of their structure. In the prepared activities, you will be able to describe the different functional group of organic compounds, explain saponification of fats as simple reaction of organic compounds, and identify the functionality of organic chemistry in everyday life. In the Let's Prepare part, you will be asked to submit a literature review of a research paper with a topic about saponification of fats. So find a research paper that tackles about the saponification of fats, review its design, and make a literature review. What does a literature review means? So in the literature review, you will find the problem, state the purpose of the research paper, materials. So what are the materials they used to do the experiment? And then method, summarize the methodology of the research. So based on what you have read, how did they perform the experiment? Finally, conclusion, explain the relevance of the research paper. Relate the research paper to our study of functional groups and saponification of fats as a simple chemical reaction of organic compounds. And then, this is the expected output since saponification of fats requires materials that may not be available in your community. So I opt to ask you to just review an existing experiment that is about saponification of fats. And then for the exercises 1, for your first activity, you will be asked to predict this statement like dissolves like. Which one will dissolve or will react with this one?
This is how like dissolves like happens. Using the electronegativity value of the elements, we can predict if a bond is nonpolar, polar, or ionic. For an orange pill, for carbon, you have an electronegativity value of 2.55 minus the value of electronegativity value of hydrogen, which is 2.20. From the formula, it is an absolute value which indicates there is no negative sign, equal to 0.35. And then for a non-vulcanized balloon, you also have a carbon-hydrogen bond, which will also give you a 0.35 value. While in the orange juice, you have this 0.35. For carbon and oxygen, for carbon, you have 2.55 minus oxygen has an electronegativity value of 3.44, which will give you a 0.89. While for hydrogen and oxygen bond, you have 2.20 minus 3.44, which will equal to 1.24. For the vulcanized balloon, so this will have a value of 0.35. For sulfur, you have 2.58, which will give you value of 0.03. 2.58 minus 2.58 equal to 0. To predict the polarity of the bond, for if your difference is less than 0.4, you have a non-polar. Between 0.4 and 1.8, this is polar. For greater than 1.8, it is ionic. So, as you observe, the values of orange peel and non-vulcanized balloon is the same. So they are both non-polar. While orange juice has a polar band, this is polar and this is polar because of this statement. And this also has a polar bond. So non-polar to non-polar will dissolve each other. While orange juice will not dissolve non-vulcanized balloon because it has a polar band of carbon to oxygen. You know? So another similarity for these two compounds is that they both have carbon and hydrogen element, which makes them as hydrocarbons. In your exercise 2, you are asked to draw the structural formula of the hydrogen compounds. So, I will give you an example of how you will draw the structural formula for ethane. So, ethane has a molecular formula of C2H6. So, the structural formula of this will be carbon, 2 carbons, and 6 hydrogen. So, 2 carbons, hydrogen. As mentioned in your reading 1, carbon has 4 available atoms to attach to other elements. So, this is 4 available atoms. And almost always, carbon having that property is always the central atom.
For exercise 3, functional groups, you will be asked to group the compounds you will see here, and please do pay attention to the new elements in the compound aside from carbon and hydrogen. And then the readings 2 is about the functional group. In this, you will learn what is the group you have analyzed in exercise 3. So you have these different classes of organic compounds, which is called functional group. These are the ones attached to a certain compound which is responsible for the chemical behavior of the parent molecule. So we have the halide, alcohol, ether, aldehyde, ketone, organic acid, ester, amine, amide. And also note that R represent a bonded atom or a group of atoms. So you can also see on the last column the examples for this compounds that has functional group. And with reference to exercise 3, name each set of molecules you have made. Find 2 examples where you may encounter these groups. So from your identified groupings in exercise 3, name the group that you have grouped. And then find and make a summary of the table of the functional group given in readings 2. So you will rewrite the functional group, write its prefix, its suffix, and the structural formula using the R as any group of atoms and an example of this, which this functional group is present. Readings 3, saponification of fats and oil. In strongly basic solutions, fats and oils undergo hydrolysis to produce glycerol and salts of fatty acids. Such reactions are called saponification reaction. And this will be discussed in detail later. This structure shows a long chain of oil-soluble group and water-soluble group. The hydrophobic, not liking water, nonpolar hydrocarbon chain, this, mixes with the nonpolar or grease molecules, this part. The length of the hydrocarbon chain varies with the type of fat or oil, but it is usually quite long. I will discuss this in detail later.
So how is saponification of fats related to functional group? As you can see, this is a chemical equation for saponification of fats. You have ester. How do we know that this is an ester? Is because of this functional group. Plus water and sodium hydroxide, you will produce a carboxylate, which is indicated by this group. This is a carboxylic acid for the functional group. But since H is missing, we call it carboxylate. And then plus alcohol, which is indicated by this group. Below is a structural example of an ester, carboxylate, and alcohol.
For exercises 5, let's play. This is a simulation of the hydrophobic and hydrophilic chain of soap. So you will perform the following procedures and write your observation in the given spaces below. Then give your general observation of setup A and setup B. And for exercises 6 from the experts, this is a practice for your let's prepare assessment. So you will read this experiment or this article, and then a follow-up question is provided to what is the purpose or objective of the cited research paper, and then what are the materials and tools used in the study, how did they perform the experiment, and what is the relevance of their research paper. How will this research paper help you understand functional groups and saponification of fats as a simple chemical reaction of organic compounds? And then you may put your answer in this space for exercise 7, the let's prepare, or you can make it printed for the literature review. Thank you. For inquiries, you may directly message me or you may ask your advisor to message me for your inquiries. Thank you.